Hello, Rio Grande third graders, and today for our math lesson, we're going to be writing to explain. We're going to be taking a look at arithmetic patterns and tables. So students, you will learn to identify and explain arithmetic patterns, which are math patterns, determine the pattern of an input-output table, and you should also be able to complete a table using that pattern or the rule. So let's get started. So as we're looking at math or arithmetic patterns, we need to remember one thing. When analyzing or studying patterns closely, we can use our four mathematical operations. So we're either going to add to get from one number to the next, or from one input to an output. We're going to subtract, we can multiply, or we can divide. Now, we haven't talked a lot about dividing, but we have focused on the other three mathematical operations. So you can use those three mathematical operations when you're looking at input-output tables. As we continue to talk about division, you will see that later on you'll have more patterns that implement or show division. But for now, we're just going to work on adding, subtracting, and multiplying using patterns in input-output tables. Now, most of the time, and in our DMA, we have been looking at number patterns. So for example, we have a pattern here. The pattern is 12, 22, 32, 42, blank, and 62. So we want to know, based on a pattern, we want to know what is going to be our missing number in this number pattern. So if we look at our tens place and all the numbers that follow 12, we can see that the pattern is adding one more 10 from each one of these, for each one of these numbers. The ones place does not change, so we can say that the rule for this number pattern is to add 10 to each number. So if we were going to go back to 42, we could add 10 and we would end up with 52 as our missing number. Now let's take a look at our idea behind input-output tables. A table pattern has an input and an output. And when we look at patterns in input-output tables, we want to look at the pattern between the input compared to the output. So for example, the input is 9, the output is 5. So that tells us that we are decreasing from the input to the output. Now let's think about, are we dividing? Well, we haven't gotten to dividing yet, so I probably wouldn't give you a table pattern or a table with that kind of pattern yet. However, we know that when you're subtracting, you should go from a greater amount to a lesser amount. So if we have 9, how would we get from, what would we have to do to 9 to get to 5? If you said subtract 4, that would be correct. So now let's look and see, does the other inputs and outputs show the same pattern? So let's look at 19 and 15. If we subtract 4 from 19, are we going to get 15? Yes, you should get 15 if you subtract 4 from the 19. If we continue to look at these patterns, 95 to 91, yes, we could subtract 4, and from 96 to 92. Now, notice we're not looking at the input pattern and then looking at the output pattern going down. There would not be a pattern in this particular case. So our rule is to subtract 4. And when we explain that, we need to explain that from our input to our output, we're subtracting 4. Now, if we look at our missing amount here from our box, we don't have an input, but we have an output. Well, what was this number before we subtracted the 4? Well, to think backwards, we would need to add 4 here to figure out what the number was before we subtracted it. So if we add 4 to 29, that would give us 33. Now we have an input of 62. We know our rule is to subtract 4. So when we subtract 4, we could think of subtract 2 because we know we have 2 here, and then subtract another 2, which would give us 58. So when we're looking at input-output tables, remember, you're looking from the input compared to its output. So ways to look at an input-output table may consist of, first, complete the table. Sometimes we allow students to complete a table when we give them the input or the output in the pattern for the rule. So for example, in your DMA, most of your input-output tables have given you the rule. It tells you what you need to do to find your output. In this case, they're saying that we need to divide by 4. So that's one way to look at an input-output table. Another way is you have to figure out the rule. And we use analysis to decide from the input to the output what the pattern or the rule is. So for example, if I look at this input compared to its output, I can see that I'm either going to be subtracting or dividing because my input is less than my output. So I'm thinking, well, to get from 24 to 8, what would I have to do? And does that follow for the rest of the patterns? So if I were to subtract, I would need to know the number between 24 to 8. But actually, we're actually dividing here. So 24 divided by 3 is 8. 36 divided by 3 is 12, and so on. That's another way to look at an input-output table. The final way to analyze an input-output table is allowing students to look at the table, discover the rule based on your analysis or your studying of the data, and you fill in the missing part of the pattern. That's what we're going to really focus in on. This is the higher level of what you are going to be doing. We can give you the pattern, but to analyze the pattern and discover the pattern on your own and be able to use the pattern is the big picture. So now let's talk about looking at an input-output table. This input-output table is going across horizontally. So when we go to look at what's happening from the input to the output, we're going to look from top to bottom. And in this case, from input to output, we notice a decrease in the pattern. This tells us that it's either going to be subtraction or division. So let's take a look at the pattern. So to get from 7 to 0, what would you have to do to be able to get from 7 to 0? Well, we'd have to be able to subtract 7. 7 minus 7 is 0. Now, what would happen if we went to the next input-output area? Well, let's see if the pattern continues. So if we subtract 7 from 8, do we get 1? Yes. And if we subtract 7 from the 9, do we get 2? Yes. So now we have discovered what our rule is. It's going to be subtract 7 from each input to get our output. So if I were to subtract 7 from 15, I would get 8. And if I were to subtract 7 from 20, I would get 13. So now we're going to take a look at an input-output table that is not just horizontal, but now we're going vertically, which means we're looking at the input-output not from top to bottom this time, but from left to right. From left to right. So we ask ourselves, what's happening from the input to the output? So to get from 1 to 21, what would we need to do? Well, we know that we're either going to add or subtract since our output is greater than our input. Now, if we think about adding, what would we add to 1 to get to 21? Well, we could add 20. If we did the same thing, does the pattern continue? Well, if we add 20 to 2, do we get 22? Yes, 22 would be our sum. So again, if we continue this pattern, adding 20, does the pattern continue as we go? So from input to output, we noticed an increasing pattern. And this tells us it's either addition or multiplication. And in this case, we're adding 20. So our rule is to add 20. So if we add 20 to 5, we get 25. If we add 20 to 10, we would get 30. So our rule or our pattern continues in our table. So now let's take a look at the input-output of a number of cages and a number of rabbits. So if I have a cage, and for every cage I have 3 rabbits. If I had 2 cages, then that would tell me that I would have 6 rabbits. So that tells me I'm using my groups, and they're equal, remember? So I have one group of 3 is 3, 2 groups of 3 is 6, 3 groups of 3 would be 9, and 4 groups of 3 would be 12. So I can see that here my pattern is going to be multiply by 3. So if I were to continue this pattern of multiplying by 3, and I was at 7 cages, notice I went from 4 to 7, and that's not really a pattern, and this is why we don't go from input to input. We go from input to output. So if I multiply by 3, I would get 21, and I could use repeated addition. And if I had 10 cages with 3 rabbits in each cage, then I would multiply by 3 and get 30. So writing to explain. We always want to, again, make sure that we are looking from input to output. And in this case, we have 91 and we're going to 87. And we notice it's a decreasing amount. So we look at the next set of numbers, 82 to 78. That is also a decreasing amount. Now, if we decide to, and these numbers are fairly close, we could count up from 87 to 91, or we could count backwards from 91 down to 87 to see what our amount is. So if we continue this pattern, we can see that we are going to decrease by 4. In this case, the rule of the table is to subtract by 4, since 91 minus 4 is 87 and 82 minus 4 is 78. Now, this is just a brief explanation to show how you can explain your input-output table. Notice I only did a couple of examples from the table itself. Again, you don't have to, unless the pattern changes, you do not have to explain all the inputs compared to all the outputs. So let's talk about our lesson for today, which is going to be in your book. So you are going to need your Envision hardback book, page 108, 109, and a piece of paper. So, if you need to pause, you may pause, but this is going to explain your assignment for today. So, let's take a look at your Envision book, page 108 and 109. This is going to be your assignment for today, which is lesson 4-5, writing to explain. You'll notice up at the top, it says problem solving, writing to explain. Let's take a look at the example problem for the day. So it says Gina's dad gave her 2 pennies on Monday. He promised to double that number of pennies every day after that for 1 week. So when you double something or an amount, you're actually multiplying by 2. So if we look at the table to the right, it's telling us that on Monday she had 2 pennies, but then when you multiply that by 2 and double that amount, on Tuesday you'd have 4. You double the 4 pennies and that would multiply by 2 and that would make 8. Multiply by 2 for the 8, and now on Thursday you have 16. Multiply by 2 on Thursday, and finally on Friday, multiply by 2 and you get 32. Now, if you were to double, and we know that when we double something, we can add it to itself. So 32 plus 32, we're doubling that amount. So we could say that would be, if you said 64, you'd be correct. And if we double the number of pennies from Saturday to Sunday, we're going to double 64. So that means we can say 2 groups of 64 or 64 plus 64, which would give us 128. So that's our example problem. You'll also see on page 109 that they give us the information that we need to solve for that. So let's take a look at our assignment for today. There are 5 questions on this particular page, and the first page says, communicate. Brian bought 3 packs of baseball cards. There are 4 packs in each. There are 4 cards in each pack. How many baseball cards did he buy? Explain how you can solve this problem. So just a reminder, I'm going to do this one with you real quickly. If you remember, we always need to, with our word problems or story problems, we're going to take our question and rewrite it as an answer statement. So, how many baseball cards did he buy is our question. So we're going to write, Brian bought blank baseball cards because, and then we're going to explain how we can solve this problem. So, if we were to say Brian had 12 baseball cards because if you have 3 groups of 4, then you can use addition to add 4 plus 4 plus 4 plus 4, or 3 groups of 4 if you were to draw for example, a bar diagram or even a model, you can see that you would get 12 baseball cards. So remember when you're explaining how to solve your problem, restate your question as an answer statement. Number 2, if the pattern in the table above continued, how many pennies would Gina get next Monday? So if you go back up here to this previous example, we would be wondering, and actually we would put another row here, and we would label that Monday, and we would put how many pennies there would be for Monday. Now, my suggestion for you would be not to necessarily copy the whole table, but maybe the last 3 days of the table, and then add Monday. So that means you'd have 4 rows in your table. Make sure to label your row with the day and the number of pennies. On number 3, it asks you to write a problem. So you're writing your own story problem. You're also going to explain how to solve it using words, pictures, numbers, and or symbols. So I would suggest that you use a couple of different ways to show how you're solving that when you're explaining. So you're writing a story problem, just like you did in your last lesson, and you're explaining how you solved it. For number 4, you're going to copy the table, and then you're going to complete the table. So just like in our lesson, this is completing the table using our rule. So we have to decide based on our input, we have the number of tables, and for the output, we have the number of chairs. So for every one table, we have 4 chairs. So you'll notice that if we visualize this, 2 tables, again, each table would have 4 chairs, so that means now we have 8 chairs. 3 tables, we would now have 12 chairs, and this pattern should continue. So what's our rule? Remember, we're looking for input to output. So if we know that one table has 4 chairs, 2 tables has 4 more chairs, we're actually multiplying by 4 to complete the table, because for every table we have another group of 4 chairs. Remember up here on part A, it says to explain the number of chairs as they change to the number of tables. So basically I just kind of explained that. Number 5. Aaron cut a log into 5 pieces. How many cuts did he make? So think about if he has 5 pieces, explain how you would find the number of cuts. This might be a really good time to take and draw yourself a picture to give yourself a visual for that. Then on your next page, which is page 109, you're going to use the same. You're going to copy the table, then you're going to explain the pattern. Remember, we're going from input to output. So in this case, our input is the number of tickets, and the cost is $5 for each ticket. So we can see that if we bought 2 tickets, it would be $10, 3 tickets, it would be $15. So this gives you an idea that, again, we're using our understanding of multiplication, and for every one ticket, we have $5 for each ticket. So by the time we get to our 4th tickets or our 5 tickets, you should be seeing a pattern from input to output. On number 7, this would be a really good idea if you were to draw a table. For example, you could have a table that had lawns mowed or raked, and for each lawn, you can see that for each lawn, he rakes for $4 and he mows for $6. So how much will Hank earn if he mows and rakes 2 lawns? So you could do a horizontal, side-to-side type of table, or you could do a table that went up and down, and instead of having one column with for each lawn, you could have 2 columns for each lawn. And one column could be raking, and the other column would be mowing, and the first column would be number of lawns. So just a suggestion, just one of those ways to use your tables like we've been talking about. Number 8, Jake planted trees in a row. That is 20 feet long. So he planted trees in a row that is 20 feet long. So we have our total number of, we have our total length of the row, which is 20 feet. He's planting trees in the row. He planted a tree every 5 feet. So again, this is a picture. It says to draw a picture and explain. So How many trees did he plant in his row? He planted, or Jake planted, blank trees in his row because, and then you can explain your answer by using your drawing and giving yourself a visual. Number 9, Alexandria bought 5 bags of oranges. There were 6 oranges in each bag. Again, think about a visual. Draw yourself a picture. Which number sentence shows how many, then she gave 4 oranges away. Which number sentence shows how many oranges Alexandria bought? So think about the question. Which number sentence shows how many oranges Alexandria bought? Again, it doesn't say how many she has left now. It's how many she bought. So make sure you're paying very close attention to the question. And number 10, Tara ran 5 miles on Monday and 4 miles on Tuesday. Teresa, we have a new person, ran 3 miles on Monday and 6 miles on Tuesday. Which number sentence shows how far Tara ran in all? Again, pay very close attention to the question because it's asking about who? Tara, right. So we always have to make sure that we're paying attention to the question. The question is what we're trying to find. Yes, we have a lot of information in there. What do we know? However, we always got to think to ourselves, what is the question asking for? So that's your assignment for today, and we will touch base on that come tomorrow and talk about that tomorrow during our meeting. Have a great day.